Here's your riddle. If Albert's peacock jumps over the fence onto Edward's property and lays an egg there, whose egg is it? Well, the answer is peacocks don't lay eggs. Maybe you knew that. They're called peahens, the ones that lay eggs. And maybe you didn't know that either. Alright, so here's the deal. This is the most practical test you guys are going to learn, and it's the one you're going to use most often, as it says here, most often on the AP exam. It's the one that you'll use in conjunction with other tests. This first video is just to help you understand the test and show a quick example. Okay, so you've got a series. It's got positive terms, and you'll be using this test even when you have negative terms, because we're going to incorporate the absolute value, the limit of the absolute value. So I'm just going to give you the general form for this test. It doesn't have to have positive terms. You just take the a sub n plus 1 over a sub n, and you take the limit as n goes to infinity. If you get a number less than 1, the series converges. The number is greater than 1, the series diverges. So that kind of goes along with what we've been talking about. If something is less than 1, usually it converges. Greater than 1. In this case, if that real number that you get is less than 1, then yes, the series does converge. And then if the L is greater than 1, the series diverges. If L is equal to 1, then this is one of those ones where we know nothing. This is like an indeterminate form. We don't know anything yet. We're just going to basically check the endpoints, and we'll show you how to do that as well. So what I want you to be thinking about, if the series does happen to be an alternating series, then I want you to think from 1 to infinity, and I'm going to start using this, n equals 1 to infinity. Negative 1, let's say, to the n plus 1 of a sub n. You're just going to pick off that part right there. You don't have to worry about the negative parts and what do you do with that. Because when you take, if you look at this, when you take the absolute value of any negative number, it's going to end up to be positive anyway. And so what you're going to be doing here is you're going to be finding the limit as n approaches infinity of the absolute value of a sub n plus 1 divided by a sub n. So you're going to find the limit of a sub n plus 1 divided by a sub n. So let's take a look at this series down here and see what happens. Okay, here's our a sub n. That's a sub n. Okay, notice the n there and the n there. Well, a sub n plus 1 is going to have an n plus 1 there and an n plus 1 there, just like function notation. Okay, so let's go back over here. And we go, alright, well, let's take this test. Limit as n approaches infinity of the absolute value of a sub n plus 1. Okay, I'm going to write it in here. I don't normally do this, but for the first time, it's a division right there. First time I'm going to write it, equals the limit as n approaches infinity of the absolute value. Now, a sub n plus 1 goes on top, so that's 2 to the n plus 1 over 3 to the n plus 1 divided by, and again, I don't usually do this, but I will do it for the first time, divided by a sub n, 2 to the n over 3 to the n plus 1. Okay, so what are we going to get? Well, first of all, we're dividing fractions, so we're going to flip the second fraction over and multiply. So we have 2 to the n plus 1 over 3 to the n plus 1 multiply by 3 to the n plus 1 over 2 to the n. Okay, so you have to, when you get to this point, you're going to do this over and over again, so don't worry about it if you don't get it right the first time, if you don't understand. But it goes back to your algebra days. 2 to the n plus 1 can be rewritten as 2 to the n times 2 to the 1, if you want to think about it like that. Usually just write a 2. Okay, divided by 3 to the, let's do this, 3 to the n times 3 to the 1, and that's plus 1, multiplied by 3 to the n plus 1 over 2 to the n. Okay, so we have a bit of a kind of a log jam here, but we can cancel things that are alike. So let's cancel the 2 to the n. And when n goes to infinity, what we have here is we've got 3 to the n plus 1. You have 3 times 3 to the n. As n goes to infinity, we can think about this, because we have a limit here. N goes to infinity. We can think about this plus 1 here. This is kind of bothering us. That's going to be, these plus 1s are going to be insignificant as the n values get really, really big. Okay, so we can think of those as not, almost think of them as like they're not even there. Okay, and then what would we have here? We'd have 3 to the n up top, and that's going to cancel with that 3 to the n. Okay, and so what do we have? We have a 2 up top. We have no more n's. So we have a 2 up top and a 3 down below. And so the limit is going to equal 2/3. Well, obviously 2/3 is less than 1. So therefore, the series converges. We say that's 0. 0 to infinity of 2 to the n over 3 to the n plus 1 converges. Alright, so you took the limit of a to the n plus 1 over a to the n. We got a number. The number is less than 1. Therefore, the series converges. And that's it. So I'm going to stop there, and I'm going to probably assign to you guys a couple problems, and then we'll continue with the next video.